Okay, so welcome everyone. I'm Bettina and I'm currently working on a computer vision application to support the work of biomedical curators. One of the most challenging aspects in this project was to make many decisions due to, after subdividing the overall task into different subtasks, we had a lot of tools or methods which we could apply to solve the different problems. And so, on the one hand, we had the advantage to having more tools or methods at our disposal, but at the other time we needed to make decisions, and more decisions than having an obvious path to go. And in today's talk, I would like to highlight on behalf of this project a bit of the strategies that I used, which make us to converge to a solution much faster in the end. So what does a biomedical curator do? I will show you a video of it. It's rather condensed way what they do in their process of extracting data like, for instance, protein names or kinetic parameters that they later fill into a database. They highlight text, and some of them work on digital documents, so on their computer, but many of them still use actual paper. And so the general idea is to film them, so we have a video stream, and to extract the highlighted areas and the text from them in the end and do something with it for further downstream applications. Okay, so the central idea, I think, what I would like highlight is that using fast feedback loops and some additional strategies that supplement this helps to find faster solutions to many tasks. And what I mean by fast feedback loops is we start with a first naive solution, let's say a minimal example, and this helps us to not overthink our problem, but rather get started soon, getting hands-on, and then use evaluation in form of, for instance, applying our solution to data. In my case, these were images, and find the next steps to take, the next methods we should apply, because now we have a first feeling of the real problem. And do this many times, so rather use fast iterations, and in each step evaluate our current solution, intermediate solution, and then make some appropriate changes to it. And this also helps us to identify edge cases, and usually we do not see all the implications of a task at the first time we think about it. So we have a certain mental model, and during our process we need to update it and to fill in missing information. And to do this, we can, for instance, test with, at best, realistic data. And we not always have this data at hand. Maybe we can generate it, or we can ask experts, or for instance, our future users, to supply us with them. And this helps, as I already said, a bit of finding edge cases and finding missing data in our mental model of the actual task. But this will not always help us to find out questioning our own thinking errors. So I highly encourage everyone to not only ask your internal rubber duck, but also talk to experts, for instance, in the field. In my case, for instance, I was not working in computer vision before, so it really helped to get some additional experience from people in my group, which had further knowledge on specific parts, for instance, image processing methods, and to run down my ideas and get another perspective on it. And actually, it helped also a great deal to have curators in my group that are supposed to use this application in the end. And they supplied me with some data of their own, so some images from their workflow. And yeah, based on that, I needed still to evaluate with the trade-offs in mind. In the first place, you wanted to have a real-time application, and in the several steps of building this application, we had different components. So imagine we would have an application which consists of 4 different components, and we would have to always have in mind that we have an upper limit of our running time. And while building every step of this pipeline, we needed to keep that in mind, to not exceed the upper limit. Okay, so let me go back to the general idea. So one of the problems was that I wanted to have the curators in the end I didn't want to interrupt their workflow so much, because I think it's highly critical if someone will implement a solution. And one of the things I wanted to give was them the freedom to set the camera somewhere else. So the angle doesn't matter so much, and also use different highlighter colors. Not everyone will use, for instance, yellow highlighting colors, at least not from what I saw and what people told me as well. So I needed to keep that in mind. And the actual pipeline we use looks like this. We have an input, which consists of a video stream. So basically a series of images. And for the text extraction part, we use the original PDF as a reference and extract images of every page from it, and then match our current image to this page and do a feature extraction on both of them to find the mapping between both of these images. And as you already saw before, you can have a certain kind of skewedness. You don't have a perfect angle of incidence of 90 degrees, for instance, but yeah, there's a lower limit to it, of course, and it also depends on the feature extraction method you are using. But it gives the people more freedom how they can use this in the end, how they can set up their camera. For instance, use a smartphone camera at some point as well. And in the next step, we need to detect the highlights and then find the corresponding bounding boxes, segment this, and then map them back into the reference image we took in the first place and extract the text from. And after that, generating some output, they requested some human-readable formats, and I wanted to have some computer-readable formats as well for further downstream applications to come. Okay, so let me show you a few of the details of this problem. One of the challenges I already mentioned was I wanted to have them different colors at their disposal, and the camera not to set up at a specific point. And due to wanting a real-time application and the upper limit of running time, we needed to have a fast feature detection method. And as a baseline, I used a swift feature detection method, but it is way too slow for what you would like to have. So I tested different feature extraction methods. And for this, I used this concept of fast feedback loops to evaluate it in every step, but first choose based on a bit of research done into the topic of feature detectors and go from there. And the robustness of the application is also key, which brings me to, I think, the most challenging part of this project at the current time, because if you have different illumination conditions, this highly complicates this whole setup. I mean, for instance, in machine intelligence, they usually use, so as far as I know, a specific illumination condition under which they all took the photos of their products and evaluate if there are some errors made in the production process. But in our case, I mean, if you have a window at home, you know that sometimes the weather is sunny and sometimes it's cloudy. And as you can see, for instance, in the examples, the upper image is taken under cloudy weather conditions and the lower one under sunny conditions. So you have to build a test set which incorporates all these possibilities to find a really robust solution. And then one of the curators supplied me with some test images as well. And after running my solution on them, I came to the conclusion that I forgot something. And my own images to test my solution on were taken with a webcam in the first place, and it takes raw camera data without any post-processing. But the post-processing software in the cameras of the curators, I didn't incorporate into my solution at this very time when I first started out. So I need to make corrections further down. And in addition, using different highlighter colors is also complicating this process way more than I would have expected in the first place. So finding a robust solution is highly complicated, for instance, opposed to matching an image to reference if you have no further constraints. So the last part, the text extraction, was also quite interesting because the PDF parsing serves here as kind of a baseline, and the problem in this kind of area is that in biomedical literature you very often have superscripted or subscripted characters. And maybe you know how PDF format works, or maybe you don't, but it's not intended to work in the direction I'm trying to go. I am trying to reverse the whole process of extracting the text, whereas it was intended to put text and render it in some way for us people to have a nice document experience. And as you can see, the superscripted and subscripted characters aren't very well extracted. So the next idea was to use optical character recognition on it and to use Tesseract, but the models trained, or let's say the models out there which you can use out of the box with Tesseract are trained on, for instance, Wikipedia, English Wikipedia. And as you can imagine, English Wikipedia also doesn't include very much superscripted or subscripted characters. The current solution we are going to use is to reclassify the subscripted characters or superscripted characters based on the fact that for certain modes, Tesseract can give you confidence levels for each single character it recognizes. And then you can threshold based on them on a confidence level and reclassify it. For instance, using a very lightweight PyTorch model you have to train before. And this will hopefully give us a better experience than if they have to copy it directly from a PDF or put it in manually. Because in the end, we would like to have a better workflow for the user than they have already. So in all of these more detailed problems I showed you, we used this feedback loop to quickly find a solution because usually there are many solutions or methods out there, especially for the part I showed you before with the highlight detection. We stick together different low-level image processing methods, and you can do a lot of these to find a solution, but you would like to find a good working solution, at least good enough for your own use case, and hopefully in finite time to get this working fast. Okay, so I hope this gives you some inspiration if you are not already doing this on your own, in your own projects as well. Or maybe you have some thoughts on extraction of text from documents. I hope I could help inspire you a bit, and I would like to thank you with this. Stay curious, and please come forward if you like to ask me some questions. You can also walk up to the PyLadies booth where I will be later on, or catch me somewhere here at the conference, or write me. Feedback encouraged.
Thank you so much, Bettina. We have a couple of questions. First one is, what is the benefit of using video data? Individual images seem to be enough.
Okay, I need to clarify the question. So is the question, why don't we use just snapshots?
I believe so. To be honest,
okay.
It's hard to ask.
In principle, we do.
Yeah.
We don't take every frame. We just, I want, only if you want to go further down this path, but the idea is to detect when the user's hand vanishes. So for instance, we can use optical flow to do something like this, and then take the next frame and analyze it. So basically we use separate images, only one frame at a time, and not analyze the whole video, but we have the setup to get these snapshots.
Okay. Great. Then the next question is, how does it work when a document contains images, figures or graphs? Are highlighted boxes detected with the same accuracy? That's a research question, I believe.
This is a great question. This is, yeah, with my first solution, this wouldn't work. So I tried this out later on. And then we stick together another several different low-level image processing methods. For instance, using differences of images and then thresholding to remove some noise as well. So this helps, for instance, with the figure part. If you can find the same parts and threshold everything else, which has not been in the image before, then you can find the highlighted areas, at least from the point in time before, so from the frame before you took.
Okay, next question, do the curators add labels to the boxes, or they just detect keywords related to chemistry? I'm
not sure how this question is meant. I mean, it's not supposed to change their workflow, at least not at the current point in time. I mean, it makes it more improbable that people will use it. They don't label anything, so they just highlight text, and later on they fill some things into a database. Sometimes they even have to calculate, I think, some reaction parameters or something like this. So one of the problems, for instance, to do end-to-end deep learning on this is some of the knowledge from these experts cannot be directly extracted. And the database formula, so the formula fields have certain kind of labels. So, for instance, there might be an actual mapping if we have additional labels for some of the extracted text words. For instance, like it's a protein or something like this. But I think this would need a deep learning solution. And what I was to do was having a lower level solution. So didn't do a deep end-to-end learning.
Okay. Next question, during the pre-processing, did you compute differences between images with versus without markers to extract the marked areas? Or would it be an idea at all?
Can you repeat, please?
Yeah. During the pre-processing, did you compute differences between images with versus without markers to extract the marked areas? Is this an idea?
Yes, this was actually the first thing I tried, because I figured that you can do differences as well. So I think with images, but so have we still time?
4 minutes, yeah.
Okay. Let me show you something related to that. Okay, so in the video you will see my hand, and it introduces some shadows, which introduces, when you take a difference of images, artifacts. And at first, I tried thresholding them, but it didn't work quite well. So given my knowledge at the point in time, I didn't stick to this, but implemented some other low-level solution, and then came back to this idea. So now taking differences of images and adding some other low-level methods is the way we use.
Okay. How exactly does the reference mapping work?
Okay. Okay, so imagine you just load down a paper from one of the open access sites, for instance, and you can then convert every PDF page into an image. And then you can do feature extraction based on every page and store them up front. And when you process this stream of images and take one of the frames, you can extract the features there as well, and then map the features to each other and find the mapping, so basically the transformation matrix after that, and use this further down, for instance, what I showed you, to map the corresponding bounding boxes to the reference and to extract the text from there.
Okay. Then the other question, what languages do you plan to support by the robust solution?
Well, at the current time, I think we would support English, but I mean, this project is intended to be an open science project. The source code isn't publicly accessible yet, but the idea is that this will be that way in the future. And if you would like to request other languages, I think maybe this could work somehow. I mean, depends a bit maybe on the language, but probably would be possible, especially with additional contributions, for instance, from other people.
Mm-hmm. And then what is the downstream application of this application? That is what the boxes are used for after detecting them.
Okay, so we are not completely decided at the current point of time what is the overall end result. Some people have certain ideas, maybe other curators will have another opinion on that. Some ideas are in the corner of, for instance, filling databases up front, but as I explained, I think this would rather need a deep learning end-to-end solution, which could also be made possible, maybe. But for instance, we could augment the original PDF papers with additional information. For instance, do named entity recognition on the extracted text, and then do some entity linking into another knowledge database and, for instance, put back links into the original document so that you can click on them and then be transferred to the knowledge base and the, for instance, ID of some protein. Yeah.
And then last question, did you try to reverse engineer the classification to see what your model is trained on? And that is high focus on white background. Have you done?
No, I didn't so far.
Okay, maybe then a suggestion for the future.
Good
Okay,
idea.
thank you for your talk and your work. And